Now, types of RAM. So RAMs are divided into two types, static RAM and dynamic RAM. Now again, dynamic RAMs are divided into two types. One is asynchronous DRAM and synchronous DRAM. Now in this lecture, we will try to study the asynchronous internal organization of asynchronous DRAM. Now we will try to design the memory gigabits. So this also we can write it as in the config, we can configure it as a 2 mega by 8 bits. 2 mega by 8 bits. Now this is the memory size, given memory size. For this memory, we need to design the um, circuit. Now for that, what to do? First we need to calculate the total number of address lines. Now after calculating the address lines, how many number of, now already in the last class we have seen that address lines are divided into row and a column. So here also, how many rows are there and how many number of columns are there, that we need to divide. Now this total 16 megabits can be written as 16 megabits can be written as 4 kilo into 4 kilo. Now 4 kilo means what? This is nothing but a higher order and this is the lower order. So this is we are using for the row. So 4 kilo means how can we write 2 to the power of 2 into 2 to the power of 10 is nothing but a 2 to the power of 12. So here we need 12 address lines for the row. But column we can't now. This is the memory array. We divided equally 4k by 4k. But column, we can't take it as directly 4 kilo. If you are taking 4 kilo means what? In each cell you are storing only one bit. But the question is given that, so at a time we need to transfer 8-bit information. So that's why you can't take 4 kilo for the column. So now if you divide the 4 kilo by 8 means what? You will get 512 into 8 bits. That is nothing but what? 512 bytes. So you will get. Now this is 4 kilo. I have written as the same 4 kilo only, 4096. And for calculating the address lines, total 12 address lines are generated. Now 12 address lines we got. Now for the another 4 kilo, directly instead of writing the 4 kilo, we are writing in the form of what? 512 into 8 is nothing but what? 4 kilo only again. So that I can also write it as a 512 bytes. Now for this is nothing but what? This is a column. Now 512 into 8 or 512 bytes, if I write in terms of 2 to the power, then 512, how can I write? 512 is nothing but 2 to the power of 9 into 8 bits, or 2 to the power of 9 bytes. Means what? How many address lines are required now? 9 column address lines are required. Now for row, it is 12 address lines, and for column, it is 9 address lines. Total 21 address lines are required uh, to design the chip. In this 21, 21 means what? A0 to A21. In this A20. So total 21. In this, for column, lower order is always we represent for the column. A0 to A8 is represented for the column selection, and A9 to A90, A20 is represented for the row selection. So now this is the upper order, higher order address, and this is the lower order address. So now the design concept, now here we have calculated the address lines. Now we will see the design. Now already we have seen that total number of rows are 4 kilo is nothing but what? 4 kilo is nothing but what? 4096. Means what? 0, row 0 to row 4095, total 4096 rows are there. And each row is organized in the form of 512 groups of 8 bits. Now, if you see here, column 0 to column 511, total we have a 512 columns are there, and each column is grouped as a 8 bits, because in the question it is given that 2 mega by 8 is given. So means what? 8 bits at a time transfer should be taken place. That's why. So we grouped the one row as a 8 bits we group it together. If we are making this 4096 as a 8-bit group, then such groups, how many groups we got? Total 512 groups. Those are nothing but what? Columns, nothing but columns. Now this is the cell, internal cell. Now these columns are connected to the sense right circuits. So now here such sense right circuits are 512 circuits are there. Now only I have shown for the first one. Now for this one. Now here we have now here data bus is connected. The sense right circuit is connected to the data bus. Now depending upon the address given. So now here if you see this is the block diagram. So total we are using the 21 addresses. In that 9 bits we are using for the column and 12 bits we are using for the row. Now after giving this address is divided. Here it is 12 bits are going here and 9 bits are coming here. So after giving the 12 address, now row address latch after giving the address to the low address latch. Now here the low address strobe bit is given. Now after giving this row decoder will select the row, one of the row. In this 496, it will select the one of the row. Now, after selecting the row, now these column bits these column addresses are given to the column address latch. But after selecting the row only, the column address strobe is given. Thereby, it will now this address will select the decoder will decode and it will select the one of the column. Now in that column, now here you can see. Now depending upon the 9 bits, it will select one of the. Now for example, if this row is selected, now in this row, if this column is selected, depending upon the address, now this whatever the data is there, that data will be placed in the sense right circuit, and after that the data will be loaded onto the data bus. Now here this is the diagram. So if the read operation is taking place, now this bit become 1 and select bit become also 1. Now by using this row address bits, it will select one row, and after that it will select one column, and in that whatever the 8 bits are there, that 8 bits are placed onto the data bus. Now here these data transfers are controlled. Data transfer is controlled by the RAS signal and CAS signal, so not by the clock. That's why the asynchronous, this name is called as a asynchronous DRAM. Now here these two bits are controlling these two signals are controlling the data transfer. So by using some signals, if we are controlling the data transfer, that is called as a asynchronous. Synchronous means what? It should follow the clock of the processor. So now here clock is not there. So by giving these strobe signals, we are controlling the data transfer. Now if you see one more concept in this is what? If we are giving the address, only 8 bits of data is selected from the given column. Now if I wanted to read the bus transfer, now if the bus transfer is required, bus transfer is nothing but what? Consecutive memory locations are supposed to be read. Now at that time, only one time the row address is given. Once the row is selected, now for example, this first row is selected. Now this row is selected. This row should be loaded into the latches. The output of the sense right circuit is connected to the latch. Now like that, total 512 latches are connected. Now once the row is selected, then the complete row information is loaded into these latches. Now depending upon the column address and CAS signal. So the for first giving the CAS signal for first column and row, in the row first column, that data is placed on the data bus. Now once again we need to give the CAS. No need to give the RAS signal and row address. Once the row is selected, that is done. Only for the column we have to give the CAS bar signal. The second one, it will read the consecutive memory, second location content onto the, it will place the second location content onto the data bus. If once again, one more time, if we give the CAS, then the third location content will be placed like that. How many times we provide the CAS signal, so thereby it will place the data on the data bus. So that is the fast page mode. For that, what we need to do, apart from this circuit, we need to add latches. Now latch at the output of the sense circuit in each row. Now if you see the asynchronous DRAM circuit, now here the clock is missing. That's why the data transfer is controlled by RAS and CAS. Now first given the read operation. Now for the read operation, now for first RAS row address strobe is given. For at the time row is selected. Now after the two clock pulses only CAS is given. Now here you can see CAS. This is high means what? Not enabled. This is active low signal bar is there. So whenever you give the active low signal, that is only enabled. So after the two clock pulses, we are giving the CAS. Thereby what? Column is selected. Now after selecting the row and after selecting the column, it takes one more clock cycle to read the data from these cells and placing onto the data bus. So after one cycle, the data is placed on the data bus. Now for the next again, immediately now this is for the consecutive four um, memory locations content we are reading. So D0 is placed, D1 is placed, and D2 is placed, and D3 is also placed. This is for the burst transfer. If consecutive locations are reading at a time means what? That is a burst transfer. Now we will study the synchronous DRAMs in the next class.